Welcome students. I know that I am very much delayed in giving the solution of the questions that has been asked, but today onwards I will try to make myself as much periodic as possible. Without saying any more things, today we are just going to solve from question number 638 to question number 641. Okay, so starting with the question number 638, which is here to be as the main objective of the governor system in power system for all types of turbines is to control the option A voltage phase angle, B reactive power input, C voltage magnitude, and D frequency. What do we know basically? We know that the voltage level of this kind of system at the generation end is totally dependent upon the excitation of the system. That means the reactive power basically related to the voltage levels. Okay, but when we are dealing with frequency, it is directly related to the active power. And where from this active power is basically coming? This active power to the alternator is being supplied mechanically from the turbine. So the governor system, when dealing with the power which is supplied through the turbine to the alternator, then the thing which is related to this or the objective is to basically control the frequency. Okay, so the option D here will be our correct answer. Okay, that means when we are dealing with frequency, that will be related to the active power, and when we are dealing with the magnitude, then it is directly related to the reactive power. I think it is clear to all of you. Okay, so this is question number 639. A galvanometer having a coil resistance of 100 ohm gives a full scale deflection when it is carrying a current of 1 milliampere is passed through it. Means basically it is carrying 1 milliampere, then it is giving full scale deflection. The value of the resistance which can convert this galvanometer into an ammeter giving a full scale deflection for a current of 10 ampere is what? Okay, that means we have to convert this galvanometer into an ammeter which will be able to give a full scale deflection when 10 ampere current is basically flowing. Okay, so what is the scenario? First we draw it. So this is our galvanometer which is having a resistance of 100 ohm. Now we have to convert this thing into an ammeter by connecting a resistance in parallel. Okay, so with this, if we want to have full scale deflection when the total current is basically 10 ampere, then for here to get full scale deflection we must have 1 milliampere of current, and the rest of the current must flow through this, means 10 ampere minus 1 milliampere. So basically this will be 10 minus 0.001, means this is nothing but 9.999 ampere. Okay, now to have this 9.99 ampere current through this shunt resistance which we need to connect here, what must be the value of this RSH? How to find that? We have to use here the current division rule. Okay, so ISH will be 10 into 100 by 100 plus RSH. Okay, and already we know ISH is equal to 9.999 ampere, and this is 1000 divided by 100 plus RSH. So this will basically give you 0.9999 is equal to 100 by 100 plus RSH. So this will be equal to 1 plus RSH by 100 is equal to 0.9999. That means RSH will be equal to 0.0001 into 100. That means this will be 0.01 ohm. Okay, so option D here is the correct answer. Now this is question number 640. So what is the question? Which terminology deals with the excitation or stimulus applied to the system from an external source for the generation of an output? Okay, this question came in CIL Management Trainee 2017, Coal India Limited. As far as we know, any type of excitation or stimulus to a system provided to get an output from it is basically the input to the system. Okay, that means excitation or the stimulus provided manually to get output is nothing but the input to the system. So option A here is our correct answer. Okay, next is our question number 641. What is the question? The efficiency of the solar cell is about how much? So here different options you can see. Generally in today's world, the efficiency of the solar cell has been improved very much, and this is basically in the range of 12% to about 20%. Okay, so basically we can take an average to be as 15%. So here the option B, which is 15%, can be taken as our correct answer. Okay, so this question came in SSC Junior Engineer Examination of 2009. So option B here, which is 15%, is our correct answer. Okay, so I hope that all of you have understood all the questions. So if you like the video, kindly subscribe to the channel for more such questions. Okay, thank you very much.